Welcome to reference types. In this lecture, we'll be understanding what a reference type is, and then we'll be comparing reference types and primitive types, and then the last thing that we'll be taking a look at is the null reference. So let's start off by understanding what a reference type is. A simple way to put it is, it's a non-primitive type. And basically, we know that the primitive types are integer, double, boolean, and those type of variables. But a reference type is basically a non-primitive type. And this includes things like classes and objects. And keep in mind, classes and objects are not primitive types. And if you also recall, what we have is called an object reference. And an object reference is a variable that refers to an object. And the reason it's called an object reference is the reference part comes from the fact that an object is a reference type. Now let's compare reference types and primitive types. So the main difference between these two different things is the difference in storage. So now let's take a look at an example where we'll be using some primitive types for storage. So let's say we declare an integer variable x to a value of 4, and then we declare an integer variable y and set it to the value of x. So at the end of the day, x is equal to 4 and y is equal to 4. So both x and y will have the same value. However, the only problem is that one of them being changed does not change the other. This basically means that if x is set to a value of, let's say, after those two statements, x is equal to 2, y will still be equal to 4. And if we change y is equal to 3, x will still be equal to 4. So changing one of them doesn't change the others. And that's what the case is for the primitive types. Now, if we take a look at a reference type, let's say we have a course object. So we say course x equals new course x. And let's say course y is equal to x. So basically we have x, which is an object reference to a course object with a name of x, as explained by the argument when we're constructing this course object. And we also know that course y has the same value as course x. So what's happening here is that x and y are referring to the same object. So if x is changed, y is changed as well. Or if y is changed, x is changed as well. And this is something known as aliasing, and it's actually a very, very bad programming technique, because if I were to say that y.name equals, let's say, y, then the value, the name of the x course object would also become y. And in that way, a programmer can unintentionally change the value of an object that he or she would not like to do. And that's the difference between reference and primitive types. So with primitive types, when you set two things equal to another, one being changed does not affect the other. But when you do that with reference types, they're allocated to the same memory, so then both are changed at the same time. And this is a bad programming technique known as aliasing. And last thing we'll be taking a look at is the null reference. So, we've been usually, for example, in the last slide, we said course x equals new course. Now, let's say we don't want to say it's a new course right now. We just want to say course x. So let's say we do that and we say course x. So we're just telling the computer that we're going to have a variable named x, and it's going to be a course object. And then you may be wondering what the value of x is at that point. At that point, the value of x is null. So basically 0, null. And a way you can check if an object is null is you can go x, or whatever the object's name is, equals null. So that's a conditional, and it will return true if it is null and false if it's not. And if, let's say, later we want to set the value of x to null, then we could go x equals null, and that'll set it to it. Now keep in mind that sometimes when you're using a null object and you try to print it out or anything like that, you could get a null pointer exception. So we'll be taking a look at errors and exceptions a little bit later, but that's basically an error or an exception, and that will prevent the program from functioning. So we took a look at reference types, which are basically non-primitive types. We compared reference types and primitive types, and we knew that there's a difference in storage because primitive types when they're set to each other, do not change values if one is changed, while reference types do. And then we took a look at the null reference, which is what the value of any variable has when it's originally declared.